Hello guys, today we have a algebra SAT problem that says if our function x to the power 4 minus x to the power 3 minus 6x squared, we need to find out what values of x makes my function greater than 0. Okay, so in other words, we need to set up this inequality. This inequality says x to the power 4 minus x to the power 3 minus 6x squared greater than 0. And I remember that in Algebra 2, we studied a little bit about how to solve inequalities. And the first step that we have to do is we need to try to factor out our expression. Therefore, if you notice this trinomial, we can get the greatest common factor like s squared. So making my greatest common factor x squared, I have x squared minus x minus 6. So I convert this trinomial in this product of this monomial and this trinomial. Okay, but our advantage is that this is a quadratic trinomial, and probably we can factor out as well. And indeed, we can factor out this trinomial like this using trial and error. X minus 3, x plus 2. In other words, my function is not x to the power 4 minus x to the power 3 minus 6x squared anymore. Now it's x squared times x minus 3 times x plus 2, and this one have to be greater than 0. But notice something. In this product, I have one factor, which is x squared. And we know that when we have a square power or power 2, whatever number I put inside, this one always is going to be greater than 0. That's why this part doesn't affect to my result, because this one is always 0. Sorry, greater than 0. Therefore, my critical points are only positive 3 and negative 2. Numeric line, critical points, and now I got 3 intervals. 1 or 2 or these 3 intervals could be my answer. I need to find out how. We need to testing any number from each interval. So because this is the methodology, that's why we're going to pick a number in this interval. For example, 4. 4 minus 3, 1. 4 plus 2, 6. 6 times 1, 6 greater than 0. Yes, positive sign. This is going to be part of my solution because it's making any number here this statement true. What about this? For example, 0. 0 minus 3, negative 3. 0 plus 2, 2. 2 times negative 3, negative 6. Greater than 0? No. Which means any number from here, okay, doesn't work with this expression. And finally, this interval, we're going to pick any number, for example, negative 5. Negative 5 minus 3, negative 8. Negative 5 plus 2, negative 3. Negative 8 times negative 3, 24. Positive sign. And my answer, according to the procedure to solve an inequality, is to choose my intervals with a positive sign, which means this part is going to be my answer and this part is going to be my answer. So how can rewrite this one? in several ways. And now we are going to use the set notation. This interval would be all numbers less than -2. Or this interval would be all the numbers greater than 3. So which means my solution has 2 intervals, the union of 2 intervals. Okay? That's it. Thank you very much. See you soon.